Okay, you are welcome back to Introductory Mathematical Analysis B. We are still in 4.4, and here we're going to be doing some more examples. Okay, so where we use the substitution method to solve. So we're going to be doing some more examples on that. So example one, want to find the integral of 2x3 plus 3x all over x4 plus 3x squared plus 7 raised to the power 4 then dx. Okay, we want to find this. This is integration. We want to find this. Okay, to find this again, we use our substitution method. Here again, we can see that this has x raised to the power 4, but this has x raised to the power 3. So it's good to make this one our u. We have to make this one our u, because by the time we derive, we're going to be getting something up to this power. Okay, so let's make that our u. Let our u to be x raised to the power 4 plus 3x squared plus 7. Okay, derive u, we get du. Derive this, we get 4x3 plus derive this, we get 6 x. Okay, let me add something, because for every x we derive, we are supposed to multiply by the x also. Then plus derive this, we get 6x dx. Then derive this, that will be 0. Okay, but here we have the x dx, so we can bring the x together plus this dx. Okay, and that will give us the u. Okay, can you see? Now if you look at what we have here, it's similar to what we have here, only that now this is 2x raised to the power 3 and this is 3x. So what can we do to make it exactly the same? We just factorize 2 out. If I factorize 2 out from there, I'll be getting 2 into 2x3 plus 3x dx. Now this is exactly what we have at the numerator, but now with multiplication of 2. So I can take these 2 away and divide the u by that. So that means I'm going to have the u divided by 2 will now be equals to 2x3 plus 3x then the x. Okay, now we can have it exactly like what we have here, what you have at the numerator here. Okay, so now let's change it now to the integral now to u. Let's change the integral to u. So this will now become, the integral will now become, let me write it nicely first. This will now be 3 plus 3x. So my dx can be written up here. Okay, all over all what we have here. All over what we have there. Okay, that's fine. So now I want to change to u. In changing to u, I want to change it to u. So this becomes integral again. Don't throw away your integral until you integrate. If not, you must carry it along with you. So this my u now. This my u. So I have u. So the whole of this is u. U raised to the power 4 now. Now, instead of this one I have at the numerator, I will now change it to du over 2. I will change it to du over 2. You see, this one is exactly what we have here. So we change it to du over 2, it become du over 2. Okay, du over 2. Of course, that means that the integral is now becoming, these two will come down, so we have du all over 2u raised to power 4. Okay, we can rewrite this to become, because this is 1 over 2, it becomes 1 over 2. Then this can come up, will become u negative 4 du. Okay, so you see we have changed it to a simpler integration now. So now we integrate now. So this is this, and this will become plus 1 u minus 3 all over negative 3 plus c. Okay, plus c. Now we can now write it nicely. Then it becomes negative u negative 3 over 6 plus c. All right. So don't forget what is our u. We must bring back what is our u. S raised to power 4 plus 3s squared. So if I bring back that, but before I bring back that, let me write this as 1 over 6 u3. I can write it as that, so which is fine. I can write it as that. So now I can now put what is the value of our u, minus 1 over 6 in terms of s raised to power 4. Is it plus or negative now? Now plus 3s squared plus 7 plus 3s squared plus 3s squared plus 7 raised to power 3. Okay, so we have that plus c. Okay, so that is our answer. Please make sure that you were able to substitute back your x. Okay, that's our answer. Okay, example 2. Example 2. Want to find 2x raised to power s raised to power 2 dx. Okay, want to find this one. Okay, we want to find this one. Again, if you look at this, this is x raised to power 2, which if we derive, we are going to get 2x. Okay, so it's good to make it our u. So we say let u equals to x raised to power 2. Then the derivative of it gives us 2x dx. Okay, gives us 2x dx. You see, so this 2x dx is just the same as this. Okay, so when we combine it together, so our original integral, which is this, can be written as this. Can be written as this multiplied by 2x dx. Okay, can be written as this. Can be written as this. And this can now become our u. So we now have e. Instead of x raised to power 2, it becomes a u. Instead of 2s plus the s, it becomes the u. Okay? And you see, by the time we integrate this, it just becomes this plus c. Okay, let me see if we add c. Yeah, we add a c. Don't forget to add your c. So plus c. But don't forget our u. What is our u? S raised to power 2. So e x raised to power 2 plus c. That's our answer. That's our answer. Please take note of that. Okay, another one. Example 3. Example 3. Want to find 7 over x dx. Okay, 7 over x dx. Alright, this is the same thing as 7 1 over x dx. This same thing as 7 1 over. And one of the rules we stated before, we said the exception we have for integration using power rule is when the power is negative 1. When the power is negative, any other value, negative 2, we use the power rule for integration, negative 4, negative half. But when it is negative 1, then we need to use this special rule which becomes ln of that x. Okay, so this will now become, if I integrate this, it becomes 7 ln of x plus c. The absolute value, we are taking the absolute value. That's why we are putting this. Ln of x plus c. All right, which is the same thing as, if we have assumed the positive value, we can also write it as ln x plus c. That means we are saying x is the positive one. Okay. All right, so we can have that as ln of that. Okay, we can use the law of ln to bring this 7 on top plus c. Okay, that is also fine. But here we are done, we are fine here also. All right, please take note of that. Take note of that. So anytime you have a -1, -1, that is the only exception, then it becomes ln. So integration of that becomes ln. And don't forget that when we're doing derivative, if y is given as ln x, when you want to derive, what do you get? You get 1 over x. And you see, so that's why the integral of 1 over x becomes ln x. Okay, please ensure that you understand. Please ensure you understand.